Determining an empirical formula. So, just a reminder, an empirical formula is a formula that has the lowest whole number possible for a chemical formula. So, lowest whole numbers. So, what is the process of finding an empirical formula when you're given percent composition by mass? Okay, so on the left here is a general workflow. If you're given a mass percent, okay, you can convert that into grams. Okay, and the easiest way to do that is assume you have 100 grams of your substance, of the compound. The reason being is that just directly convert your percentages into grams. Okay, 24.75%. Okay, convert that into a decimal. You have, if you were to take our example here, that would mean that if you have 100 grams of the substance, 24.75 grams would be potassium. 34.77 grams would be manganese. You get the idea. And 40.51 grams would be oxygen. I know my G, the G looked like an 8. So grams. So now you have masses of your compound, if you assume 100 grams. And then next is you must convert these to moles. And we'll talk about why that is momentarily. But to convert from grams to moles, by this point you've done conversions, you use the molar mass. So if we look at the periodic table, the molar mass of potassium is 39.10 grams per mole. Manganese is 54.94 grams per mole. And then oxygen is 15.999 grams per mole. And that's how you're able to convert from grams to moles. Grams cancel, and you're left with moles of each of these elements. Make some room. If we do those calculations, I'll pause it, just write the numbers underneath. There are the molar amounts for each chemical, for each element in the compound. But chemists don't record compounds as decimals or fractions. They use whole numbers. For example, if I were to use these molar amounts for my formula, K 0.6329, M N 0.639, and oxygen you get the idea. 2.532, and that's just a mouthful for one, and it's just not practical to use those values. But what these are is a ratio. You can convert them into a ratio that makes more sense. Okay? So you divide, the next thing is you divide by the smallest ratio, or the smallest number. Okay, we could pick either potassium or manganese. And oxygen's a little messy there, but we'll come down. So for oxygen, 2.532 divided by 0.639, and all units of moles. And then that's a way of making all of these whole numbers. Remember, when you read a chemical formula, whether it's chemical or empirical, you can say that, well, we'll do the calculation first. And if you do that math, you see that the formula is going to be KMnO4. That's 1. That's 1. This number divided by that lowest molar coefficient is 4. Potassium permanganate's the name of this chemical, but you would read it as it's got 1 mole of potassium, 1 mole of manganese, and 4 moles of oxygen in the empirical formula. Or you can say 1 potassium atom, 1 manganese atom, 4 oxygen atoms. That's the process. Convert to moles because chemical formulas can be read as either by atom or by mole. Here's another example of a typical empirical formula problem that you might encounter, where this one differs from the previous one, is you're not given percentages. Okay, you're not given percentages of your component, but the key to this, working this type of problem, is you have to recall the law of conservation of mass, which states in a chemical equation or in a chemical reaction that matter is not destroyed. That means that the mass of matter in your reactants must equal the mass of matter in your products. So in this problem, we've got 45.2 milligram sample of phosphorus. And it reacts with selenium. The question doesn't tell us how much, to form some selenide. So on a compound nomenclature, you've got phosphorus, selenium. I use X and Y because we don't know what those subscripts are. We just know we have some selenide, but we know it weighs 131.6 milligrams. So if the conservation of mass is true, and it is, that means that the sum of the masses on this side must equal the sum of the masses on this side. So we can figure out what the mass of the selenium is. If I put those numbers in, the mass of the selenium on the reactant side is 86.4 milligrams. So now we have masses that we can work with. And we follow the procedure that was appeared earlier in the play posit. We go from mass to moles. And then we go from moles to whole number, subscripts. So first, I'm going to convert milligrams to grams because molar masses are given in grams per mole. So if we have 0.0452 grams of phosphorus, I'll look up its molar mass on the periodic table, and what I get is 30.974 grams per mole. Selenium, convert it to grams, divide by 1,000. Look at the periodic table. Its molar mass is 78.971 grams per mole. Grams will cancel, and we're left with moles. We do those calculations. This number for phosphorus turns out that we've got 0.00145 moles. Then for selenium, we do that math. .001094 moles. So now we choose the one that is the smallest as our common denominator, so to speak. But we divide both numbers by our smallest value. 145, 109. So this is the smaller number. That math, get 1.333 moles. And here, this is 1 mole. Everything divided by itself is 1. So what do you do when you don't get a whole number the first go round? Okay, if we were to put this in as a formula now, we would have P 1.333 SE 1. Chemists report whole numbers. Just makes it easier for everyone. So what you do is you multiply until you get a whole number. For example, let's just say we've got that 1.33, we multiply it by 2. Okay, we just multiply by some whole number to normalize that value to make it a whole number. That's going to be 2.666. Okay, it's not a whole number. Okay, so that whole number doesn't work. Selenium at this point, you have to multiply it by 2, and that would become 2. What do we do if we take 1.33 and multiply it by 3? Hopefully you can see that 0.333 is the same fraction as a third. But 1.33 times 3 is roughly 4. That's a whole number. So the proper formula for this compound would be P4 Se3. Again, why that is 3, we have to multiply both the numbers above by the whole number that gives us a whole number. 1.33 times 3 is 4. 1 times 3 is 3. That's how you go about solving that type of problem.